So a pure substance can be homogeneous or heterogeneous. It's typically homogeneous, and a mixture is typically heterogeneous, although it can be homogeneous. So by just looking at a sample of matter, you can't really tell if it's pure, made up of just one substance. So there's a more definitive way of determining whether you have a pure substance, if whether your sample is a pure substance, and that is by determining the melting point or the boiling point. Pure substances have a sharp melting point and a sharp boiling point. What does that mean? When we say a sharp melting point or a sharp boiling point, the word sharp here means that the temperature remains essentially constant. And for practical purposes in a laboratory, you say within 1 to 2 degrees while it's melting or boiling. So if you continuously heat it, the temperature will remain more or less constant while it's melting and while it's boiling. If that doesn't happen, okay, then if while it's melting the temperature is rising or while it's boiling the temperature is rising, then that means it's not a pure sample. So what would be a sketch of temperature versus time? Anytime you're asked to sketch something versus something, the first number, the first quantity you're told to sketch should be on the y-axis. So this is temperature versus time. So it's always y versus x. So time right here. So over time, if you're heating a pure substance, what would happen to it? Well, let's imagine it starts off as a solid. So your solid is temperature is gonna rise, right? So your solid here, over time, if you're heating it, okay? So this is time right here. So over time, if you're heating it, the temperature is going to rise. What happens when it starts melting? While it's melting, the temperature remains more or less constant within 1 to 2 degrees. So this is what happens when your solid is melting. Eventually, what happens? Everything gets melted, right? And so that's when the temperature starts to rise again. Okay? And then once it starts boiling, while it's boiling, the temperature will remain constant again. So this is a liquid here, and this is your boiling mixture. Now boiling temperature. Okay, so this one right here, the temperature here is your melting point, T sub m. And this temperature right here, where it stays constant while it's changing into a gas, it's your boiling point. Right, that's what it looks like. And once everything's vaporized, what happens? Then the temperature of the gas can continually go up. So this is what you have your gas.